today we're just going to be practicing what we had done last week on Wednesday and Thursday with the z-scores and the normal distribution. So remember, what you're going to do first, you're going to find the z-scores for the specific test scores or weights or whatever it is that they're talking about, whatever value it is that they're talking about. You find the z-score, then you're going to figure out what the lower and the upper boundary would be, and then you plug it into your calculator and you round to wherever it is that it wants you to round to. If it says percentage or percentile, you have to multiply that number by 100 to go from a probability, which is less than 1, to a percentage, okay? So for number 1, the scores on a test have a normal distribution. The mean of the scores is 40 and the standard deviation is 6. What percentage of people scored between a 34 and a 46 rounded to the nearest tenth? So what you're going to do, the mean is 40, standard deviation is 6. We're looking for in between two numbers, in between a 34 and a 46. So if you want to draw this curve first, you can. Right? So a 34 is somewhere below the mean, and a 46 is somewhere above the mean. We're trying to figure out what the z-score is of each one. That way we can plug it into the calculator. So for 34, do not put an equal sign because 34 is not going to be equal to this. You would do, again, the formula to find the z-score is the value minus the mean divided by the standard deviation. You can type this whole thing in your calculator, you get -1. Then you're going to do the same thing for 46. Okay, so this right here, this 34, that z-score is -1. So now for 46, you would do 46 minus 40 divided by 6. Now that's going to give you +1. Now if you remember from a few weeks ago, we said that the percentage of people between a -1 and 1 is about 68%. That's the empirical rule. 1 standard deviation away, going in both directions, represents 68%. 2 standard deviations away represents 95%, and 3 away represents 99.7%. However, this wants it rounded to the nearest tenth, so you actually have to figure that out. So in your calculator, you're going to press second vars, and then you're going to go to normal CDF, which is number 2. Your lower boundary is -1. Your upper boundary is +1. The mean you keep as 0. Standard deviation you keep as 0. Press enter. And this is what you're going to write down. You're going to write down what you see. So it says normal CDF, and then the lower, the upper, the mean, and the standard deviation. So it should always have 0, 1 on the end. So that gives you 0.682, blah, blah, blah. It wants to know the percentage. So you have to take that number and multiply it by 100. So times 100, and then we're rounding to the nearest tenth. So final answer is 68.3%. And that's it. So again, that number rounds to be 68 if you round it to the nearest whole. So that's why that's where the empirical rule actually comes from. For number 2, the amount of time that a teenager plays video games in any given week is normally distributed. If a teenager plays video games on average, or an average, of 16 hours per week, standard deviation of 2 hours, what is the probability of a teenager playing video games between 15 and 19 hours a week? So we have to figure out the z-scores for each of those. Okay, so we have 15 hours a week and 19 hours a week. To figure out the z-score, you would do the value minus the mean divided by the standard deviation. That gives us -0.5 or -0.5. That's right here. That's going to be your lower boundary. Then for 19, you have 19 minus 16 divided by 2 is 1.5. That's going to be your upper boundary. So in the calculator, you press second vars, number 2. Your lower boundary is the smaller z-score. Oh, sorry. Normal CDF. This is going to be a C now. Normal CDF. So you have your lower is -0.5. Your upper is 1.5. The mean is 0. Standard deviation is 1. Press enter. That gives you 0.624, blah, blah, blah. We're rounding to the nearest hundredth, so 0.62 is your final answer. Okay? So 62, so again, whenever it's talking about probability, the probability always has to be less than 1. So if it says probability, do not multiply this number by 100. That's only to go from the probability to the percentage or the percentile. Number 3, a shoe manufacturer collected data regarding men's shoe sizes, found that the distribution fits the normal curve, meaning it's normally distributed. If the mean shoe size is 11 and the standard deviation is 1.5, find the probability that a man's shoe size is at least 12.5. So 12.5 is bigger than the mean, so that's going to be on the right side of your curve somewhere. And we're saying at least, which means it's going to be 12.5 or more. And that keeps on going. Because I don't have that upper boundary here, right, this keeps on going, this is going to be a 10. It's either going to be negative 10 if you're on the left, positive 10 if you're on the right. So you only have to calculate one z-score here because you're going to use the z-score being 10 for the upper. You have to find what is the z-score for 12.5. Do not do an equal sign there. For 12.5, so you would do the value minus the mean divided by the standard deviation. That gives you a z-score of 1. So that's going to be your upper boundary. So we have normal CDF. So you're going to go right in the calculator again. Normal CDF. We have 1 is the lower, 10 is the upper, 0 is the mean, 1 is the standard deviation. That gives us 0.1586, yada, yada, yada. This says to find the probability, so we do not multiply by 100, and we are rounding to the nearest thousandth. So if we round this number to the nearest thousandth, we get 0.159 as our final answer for number 3. Number 4, the weight of a bag of pears at the local market averages 8 pounds with a standard deviation of 0.5 pounds. The weights of all pears are normally distributed. What percentage weighed less than 8.25? So 8.25, that's more than the mean, so that's going to be on the right side. And we want to weigh less than that. So we're below that z-score. So because there's no boundary on the left side, meaning your lower boundary, that's going to be a negative 10. We do, however, have to figure out the z-score for 8.25. We have to find where that is precisely on our curve. So we would do 8.25, the value, minus the mean, divided by the standard deviation is 0.5. You type that in, that gives you a z-score of 0.5. Now I know that that's a small number, but that's your upper boundary. It goes from left to right, so that's going to be the upper boundary. 0.5 is bigger than negative 10. So you're going to do normal CDF, lower boundary, upper boundary, mean, standard deviation. That gives us 0.69146. We are finding the percentage. So we multiply that number by 100. You can do it right in the calculator if you want. And we're rounding to the nearest hundredth. So your final answer should be 69.15%. And last one. Last one's talking about the percentile. Again, the percentile, a lot of us got this mixed up on the last homework. The percentile, let's say you're finding the percentile for this score right here. Percentile is always less than that number. So for example, if you have a really high percentile, you're really far over this way. Okay? If you have a low percentile, that means that so if you have a high percentile, that means that there's a lot of people below you. If you have a low percentile, then there's not a lot of people below you. Okay, but it's always where you're at or less than that. So you're always going to shade to the left when it's talking about percentiles. Okay, so the scores on a standardized exam have a mean of 82 and a standard deviation of 4. Assuming a normal distribution, determine what percentile, so that's why I brought that up, determine what percentile rounded to the nearest integer. An integer is a whole number, right? We know that. A student score of 87 would rank. So again, this is our curve. 87 is above the mean, which means it should be more than the 50th percentile. Okay, the mean is exactly halfway through. So that means that you're 50%, there's 50% of people above or below you. Okay, if you're above the mean, you are at more than 50th percentile. If you're below the mean, you are less than the 50th percentile. Okay, so this score of 87 is above the mean, which means that our percentile should be more than the 50th. So because we know that we're going to the left, my lower boundary is -10. To figure out the upper boundary for 87, right, that's the score we're looking for, you would do the value minus the mean divided by the standard deviation. That gives us 1.25. So we have 1.25. So from here, it's pretty much just figuring out the percentage, just like what we were doing before. So we have normal CDF, -10, 1.25, 0, and 1. You type that into the calculator, that gives you 0.894. Again, percentile means that it's percentage, so you multiply by 100, which gives us 89.4, but we're rounding to the nearest integer or whole number. So it is the 89th percentile. Okay? And again, more than 50 because it's more than the mean. All right, let me know if you have any questions. This is due at midnight, and then tomorrow you're going to have one more practice worksheet. And then we're going to move on to some other stuff with stats. Okay? Have a great day.